So in this video, we'll try to introduce the topic regarding the part 1 of the fundamental theorem of calculus. For the part 2 of the fundamental theorem calculus, we have described it already in the previous videos, and anyway, for this video, it's about the part 1. So for example, if I let the function of g of x to be the function here, so please read the notation carefully. The things that on the right hand side is like we have to do an indefinite integral for the function small f of t, and this one itself, because it's an indefinite integral, is a function of t. And after getting this, we have to look at the definite integral from a to x, right? After replacing a and x, we expect that this one becomes a function of x. And let's just look at an example later. The fact is that if you take the derivative of the g of x, it's actually very simple because it's the same as f of x. And it may be very abstract to you what I'm talking about here. Just a minor note here, a is a constant. It does not matter to us whether the constant is 0, 1, etc. It doesn't matter. But anyway, if you have certain setup, the function of x, g of x is defined in this way. G prime of x is gonna be just the function inside the integral sign. And in case you're confused, we can actually do an example about that. So for example, please look at the red color. Let's say the function f of t is defined by 2t, and we can try to do this calculation. Let's say the constant is 0, and we can try to do the integration about that, and the antiderivative of 2t is obvious. We can use t squared to be the antiderivative of 2t, and we have to take the difference of these values when it replaced by x, which is the upper limit, minus the same item when t is replaced by 0. And let's do the calculation together. So you see the first term is x squared when you replace t by x. The second term is 0 squared. So the whole thing is x squared. So what does it mean? So it means g of x now, which is defined by what I said here, the definite integral from a to x for the function 2t, which is small f of t, is going to be x squared, right? So g of x is just x squared, which means g prime of x is 2x. And it's a simple illustration of what we are doing here. Instead of doing all these calculations, we can directly write f of x be the g prime of x. F of x is what? F of x is just 2x, right? Because f of t is 2t. And as you can see, based on the simple example of our stuff in the red color, we understand that this theorem is actually correct. We understand this fact. And let's see how it facilitates our calculation of derivatives when the g of x is defined this way. So please look at the current example now. G of x is defined in a complicated way as a definite integral from 0 to x for a pretty big fraction t to the power 4 divided by 1 plus t to the power 6. Anyway, if you look at g prime of x, it would be a very challenging exercise if I asked you to find the indefinite integral of this first. It's going to be a challenging exercise. It's not something that easy. So let's drop this process instead. We can directly go through the part 1 of the fundamental theorem of calculus, g prime of x. We can just replace the function f of t to be f of x. So f of x is what? I can just replace t by x. So the answer must be the same as x to the power 4th divided by 1 plus x to the power 6, right? And that's basically the answer to the problem. And let's look at more problems. So please look at the current problem for the definition of g of x. And please notice that we cannot apply the theorem on the top page here because the x term is actually in the bottom, right? We only apply this formula when the variable x is at the top. So what we can do is we can swap the upper and lower limit, but in that case, we need to add a negative sign in front. We are allowed to swap x to 4 and 4 to x for the same function, for the same definite integral, but there's a minus sign that comes out. So you are differentiating this, and by this formula here, we understand that the answer is just the same as the function itself, but you have to replace t by x. And of course, there's a negative sign here, which is the final answer to this problem. And next, please look at the current problem. Please note that the upper limit is x squared. It is not x. It's like a function of x. And it would be wrong if you think that g prime can be obtained by just replacing x squared inside for the replacement of t. It would be totally wrong, because the fact is that this one only for only for the case where the function is the same as certain constant to the variable x for the function that you talk about, right? And anyway, this one is wrong. Something must be missing, because now the top is actually x squared. So anyway, let's look at the problem from the perspective of chain rule. So g prime of x, by definition, is the derivative corresponding to d dx, right? And dx for the g of x. And but to apply the formula we have for the fundamental theorem of calculus, we can pretend that we can differentiate the g of x with respect to the variable x squared first. And of course, we have to multiply to the second factor by an application of chain rule for the derivative of x squared, which is easy to obtain. So anyway, this one is a chain rule application. We've seen it quite many times in the topic of chain rule. So anyway, let's look at the problem this way. So now you have a very big function of x squared here, and you have to take derivative corresponding to the function x squared. And the second term is clear, which is 2x, which is the derivative x squared, right? So this one is clear. The first term is also quite clear now, you see, because the point is that we can apply the fundamental theorem of calculus here, which means we can just replace x squared for the t, right? So that's basically the answer. That's basically the answer. So now let's look at more examples. So please look at the current example, which is quite similar to the last one in the sense that the upper limit is actually a function of x instead of the variable x. So we can do the similar application of chain rule. The fact is that the second factor, due to the application of chain rule, you need to find the derivative of sine x, which is cosine x by formula. So the first factor is actually the derivative for this function with respect to the function here, the function sine of x. So as an application of the fundamental theorem of calculus, the derivative is going to be tangent of t squared, and t is replaced by sine x. So I can write it this way. And that's the answer to this problem. As you can see, it's still quite an easy application, even if the upper limit is not x, but it is a function of x, right? Because we just need to apply the chain rule once. And let's look at another problem. So please look at the current problem now, and this case is even worse, because in the upper and lower limit you actually have both functions of x, which means that we cannot apply the fundamental theorem of calculus easily, because usually the lower limit must be constant for us to apply the fundamental theorem of calculus. But we can play a trick around that, because of the fact that we can think of this kind of definite integral by an informal notation. We can think of it as the first one from 0 to 3x plus 1 plus the second one maybe from 2x to 0, right? And this property is always valid, because definite integral from a to b plus definite integral from b to c for the same function is the same as the definite integral from a to c. And anyway, I'm using this fact, so I'm kind of breaking it down into two parts. And the second part is going to be the definite integral from 2x to 0 for the same function. So I'm just using this fact for the properties of the definite integral. And now we need to do the derivatives for the two terms separately. And the derivative for each term, we have to do it term by term. For the first term, it's a chain rule application. The second factor is derivative of 3x, which is 3. And this one is the application of fundamental theorem of calculus, which means I use the same function as the function inside the integral. But we need to replace t by the upper limit, right? Which is 3x for t now. So that's the answer, at least for the first term. For the second term, the lower limit is the function of x instead of the upper one. So we need to do a swap. Similar to what we have done in a previous example about that. And after swapping that, what we need to do is we keep the minus sign in front, and which is for this. And once again, there are two terms regarding the application of chain rule. For the second term is the derivative of 2x, which is 2. For the first term, you need to use the fundamental theorem of calculus FTC, by looking at this function, but you need to replace t by 2x, right? And that's basically the answer to this problem.